Okay, so in our last lesson, we were looking at the idea about factors and how factors lead to powers. And so we were looking at how to write bases as an expression of powers. So here we were looking at how all these sevens, we counted them up, we got a base, then we wrote it to the power of 5. So 1, 2, 3, 4, 5. We know that the big number is the base. The little tiny number is the exponent. It's like the little backpack that the number wears. It gives it its superpower, right? Okay, then in the next one, we were able to find the value of that power. We were able to find the value of the power by finding how much was in that backpack, right? So like this 7 was carrying around, really it had like 2 7s in its backpack. So it had 7 times 7, which was essentially 49. So in this backpack, it had 5 to the power of 3, which was like carrying around 3 5s, which was a total of 125. So go ahead, read back your essential question, your answer to your essential question about in your own words, what you said about how to find the value of each power. And now we're going to look at how do we identify perfect squares. So how do we identify perfect squares? So first though, we need to think about what is a square? And what does the word perfect mean? So we're thinking about squared and we're thinking about perfect. So I want you to think about both of those two words, and I want you to give yourself some time to just kind of think about what those two words mean. Perfect and square. Okay, now I want us to look at some numbers. We're going to look at some numbers, and we are going to see if we can see a pattern. So we have some numbers. We have some numbers right here. Let's look for a pattern. 1, 4, 9, 16. Do you see any patterns yet? 25, 36. Are you seeing any patterns? If you were seeing a pattern, you might say that the next number in the sequence, if you were looking for a pattern, you might think that the next number would be 49. After 49 would come 64. Can you guess what the last one in my pattern is going to be? Yeah, it's 81. For those of you who got my pattern, let's talk about how we got our pattern. We got our pattern by saying 1 times 1 2 times 2, 3 times 3. Are you seeing it? 4 times 4. 25 gives us what? Right, 5 times 5. So if you kept doing this and went all the way up to 81, you would see that 81 is just a pattern of 9 times 9. So perfect squares, if you can get this pattern here, you can see the idea of squares or squared. Okay, so squared means a perfect square. I'm going to pause this for a second because my dog is making a lot of noise, and I'm sorry about that. Okay, So this idea of squares, we know that squares have equal sides and equal lengths. So a 1 by 1 square is just 1 by 1. So this idea of 1 times 1 equals 1. So a 2 by 2 square would be 2 by 2. So it would give us this idea of having 2 squares by 2 squares, which would equal 4. So we go a square, and I'm going to cut this one so that I have 1, 2 by 1, 2, and this equals 2 by 2, and this equals 4. So this idea of a perfect square comes from things that are perfectly even on both sides, right? So 2 by 2, 1 by 1, 4 by 4, 5 by 5. So how do we identify perfect squares? Well, we identify perfect squares because they have equal lengths by equal widths, or they are squared numbers. Okay, so they have equal lengths by widths, or they're squared. Okay, or it's a perfect square because the whole number, it's 2 of the same whole number. Let's use that word factor. And so let's look at this. So if I had the number 64, for example, let's use another color here. Let's do example number 1. If I had the number 64, 64 would be 8 times 8, which is the same thing as saying 8 squared. So 64 is a perfect square because 8 times 8 is 8 squared. Let's look at like the number 20. Okay, so this is example A, and let's do example B. Let's look at the number 20. Is 20 a perfect square? Can we make 20 into a perfect square? If we're using this idea of 1 by 1, 2 by 2, how do we make 20? Well, 20 is a 1 by 20 or a 4 by 5. That's how we get to 20. So 20 is not a perfect square, because there are no 2 numbers that give it, there are no 2 factors that go together that make it a squared number. So it can't be a perfect square, because if I were to draw this out, and I had 1, 2, 3, 4 by 1, 2, 3. Well, okay, those are supposed to be even, so pretend those are even. Sorry, guys. Okay, so if I had 4 by 5, and that equaled 20, again, not a perfect square. And this example really shows you that it's definitely not perfect. Sorry, guys. Definitely not perfect. Okay, so not a perfect square. So on your own right now, I want you to do 2 triads. So you are going to do 2 triads. Let's give you some triads here. I want you to do triad number 1 if you were in your book. I'm sorry, no, it's not triad number 1. It is triad number 9 because we did triad number 1 yesterday. So triad number 1 says 25. I want you to tell me how and if this is a perfect square. If it is, I want you to tell me how you make it a perfect square. And then let's do try it number 11. I want to know if try it number 11 is a perfect square because it says 99. So tell me which ones are perfect squares and how you know. And then down below, I want you to answer your essential question in your own words. How can you identify a perfect square? And then I also want you to tell me out of three, how do you know what your rating is? So go ahead and pause the video right now if you don't want to hear the answers, because I'm going to solve both of these right now. Okay, so 25 is, yes, it is a perfect square. Perfect square. My goodness, Miss Englander cannot talk today. It is a perfect square because we go 5 by 5, or 5 times 5, and that gives us 5 squared. That's how we get to 25. 99. Well, 99 I know is 9 by 11. I also know that I can make a square by going 1 times 99. So neither of those are perfect squares. So this one cannot be a perfect square just because it doesn't have 2 of the same exact number. So not a perfect square. Okay, again, down below, go ahead and tell me. Answer your essential question. How do we identify perfect squares? Write that in your own words. And then off to the side, I want you to tell me out of 3, how do you feel about perfect squares? 3, I totally understand perfect squares. 2, I kind of get it. I just need some more practice with it. 1, I have no clue what Miss Englander did. I'm going to go back, rewatch this video, and definitely pay some more attention and maybe make sure that my drawings look better than Miss Englander's. Okay, when you're ready, go ahead and turn the page. If you're not ready, hit pause, and then turn the page when you are ready, because I'm going to go on to the next part. Okay, example 4, which is modeling in the real world. So we want to know, how do we model powers in the real world? How do we model exponents in the real world? How do we model exponents in the real world? That is our essential question on this example 4. So how do we model, I'm going to pause again because my dog, sorry. How do we model exponents in the real world? So in the real world, let's say that we are playing a game of Monopoly. You know, the game with the little tiny houses and all the money, and somebody always has to be the banker, and then you pass go, collect $200, don't pass go, whatever. Okay, so let's say that we have a life-size Monopoly game board, and the game board is a square. Okay, so on the game board, we have, let's say we're playing Monopoly. All right, there we are. We're playing Monopoly. There we are. Okay, and our game board that we're playing has a side length of 11 yards. So we know that our game board is 11 yards. And it's a perfect square. Oh my gosh, look what we just learned last time is going to apply to just now. So we have a game board. Let's draw this out. It's a perfect square. And one side, they tell us, is 11 yards. Okay, so we have 11 yards. And if one side is 11 yards, then we know that the other side has to be 11 yards also. Okay, so 11 yards by 11 yards is the same thing as saying 11 times 11, which equals 11 squared. Well, we know that 11 times 11 is 121. So if I did 11 times 11, or 11 squared, I know that the value of 11 squared is 121 yards. So my board, my Monopoly board here, is made up of, and we're going to square that because it's the area of the board. How much the whole entire board is square yards. So this is where the area comes in. So we have done 11 by 11, and we have found 11 square yards. So 121 yards squared is the total area of this Monopoly board. That's how far we've had to send the little shoe piece around the board. Okay, I want you to try to do one on your own. Ooh, here you go. Let's pretend that we're out at recess. I don't know how many of you out at recess. Here's your try it. And this is try it number 20 if you're looking on your ebook. So try it number 20 says that you are playing a wicked game of Foursquare. Okay, so here you are. You're playing a wicked game of Foursquare. You've got this ball, and you have to hit it from one of your squares to the other. And from here to here, so that one little square there is 6 feet. And they want to know how many square feet is the entire playing court. So on your own right now, I want you to go ahead and solve how many square feet are you and your friends, or frenemies at this point, because you know you're playing Foursquare in a battle. So let's be honest here. How many square feet is this playing area? All right, hit pause so you can solve this on your own, because I'm going to solve it too. All right, here we go. So I know that this one is 6, so I'm also going to add 6 more over here. So I know 6 plus 6, that gives me 12. So one side is 12 feet. So one whole side is 12 feet, which means since this is a square, the whole thing is a 12 by 12. 12 by 12. So this is 12 squared, which equals 12 times 12, which equals 144 feet squared. Okay, check your work. How did you do? Okay, now I want you to go back, and I want you, at the very end of this, I want you to tell me in your own words, how do we turn factors into exponents? And I want you to identify any areas that maybe you still need to study for your quiz, and anything that you still have questions on so that you can ask for help tomorrow. So, in your own words, please tell me, how do we turn factors into exponents? Is there something special about those? Can I just use any old factors and throw them all together? Do they have to be special factors? You tell me. And then off to the side, I want you to tell me, how do you feel about Chapter 1, Section 1 overall? What's your rating for Chapter 1? Section 1 overall. 3, I feel fantastic. I am ready to take on this quiz. Give it to me now. 2, I am going to practice some more. I might hit up some IXL practice. I'm going to go back, look for some more try-its. I am going to review the videos. 1, I still have no clue what missing letter is doing. I really should have been asking questions so that I'm not lost, but here I am. I'm lost. I didn't ask any questions. I didn't demand to understand, and I need to demand to understand. So tell me, where are you, so that we are ready for our quiz, And when you're done, head on over to do your extra practice work that you have for the assignment for this.